I ask you to, this is, if I ask you, take this, all right, so now if I ask you to evaluate f of 1/2, now see, this is what they will get, this is what they do on the test. They will ask you to evaluate f of 1/2 using a Taylor, okay? And if you don't use a Taylor, you're not going to get credit for it.
Okay.
Okay, because it's easy enough, you can obviously put 1/2 in here, all right? Get 1, e to the 1 is e. There's my answer. What's so hard about that? But you didn't do it with a Taylor.
Right.
Or McLaurin, whatever case. So, you've got to make sure that you read the directions. Now, this is actually a McLaurin, because I didn't give you the center. And don't be tricked, because I almost did that when I first looked at it.
1/2 is the center?
That's not the center.
Yeah.
That's just saying evaluate, find f of 1/2. All right, so if they ask you to do that, then we know we're going to do 2x, and then since I said 3, we're going to go to 3. That would be 4 equal to 2x. And then the third derivative
The
is
8e.
Then you'd plug in your 2e, your 0, right?
Right.
Okay, because remember you're finding the, e to 0 would be 1. So f of 0 is 1. 0 here would be
2.
2.
4.
And 8. And then you'd write out your
Equation.
polynomial of third value is
F.
1 plus 2x minus 1 to the 1 over 1 plus 4.
X.
Well,
No.
x minus 0, tear, 0, 0, chlorine.
Square root.
Square root, and then, so, I'm not gonna finish. Okay, then you write third.
Then you plug that
Then
in
you
for
plug in
X.
the half, okay.
Okay.
All right, so then you'd say P of 3 of 1/2 is. Now, is that a polynomial?
Yes.
All right, and that's the polynomial you're evaluating. Okay. So would you put an equal sign or an approximate sign?
Approximate. Well, no, it equals because you're using Taylor.
Because using P3.
Are you actually using this polynomial to get your answer?
Yes.
So that would be an equal sign, wouldn't it?
Yeah.
All right. Now, what if you said it this way, though? E to the 2x, would you say it equals or approximate?
Approximate.
Because e to the 2x is not this, is it?
No.
It's just a representation of e to the 2x. So e to the 2x would be approximately what this comes out to be. All right. So depending on how you title it, the question. Now, what did they ask you to find?
F of the 1/2.
All right, so we have to make sure that we answer their question, don't we? All right? Okay. Now, is it equal or approximate for f?
Approximate.
Approximate.
There we go. Whatever the answer is. For.
So you still plug it into the
The P.
polynomial?
Mhm.
Yeah.
Okay.
You plug it in the top, you're in trouble, because that's the exact value.
That's
So all you're doing is the same thing you did on the 4 problems from yesterday, except now you are
Adding
plugging
value.
it in. Plugging it in. Okay, so that's not a big deal. All right, so there's first one, right? Okay. Now, did we use all right, did we use only 4 terms to get the answer to this problem?
Yes.
To get an answer for the problem?
Yes.
Only use 4, right? Well, what would happen if we added another term? what's gonna happen to our answer?
It become more
More accurate.
More accurate, if I added a sixth one.
Be more accurate.
So, we could add terms forever, couldn't we?
Right.
Yeah.
Okay, all right, so the more terms you do, the better your answer gets. Well, since we stopped here, we left off all this mess back here, didn't we?
Yes.
All right, guess what all that mess is called?
Remainder?
Or
Error.
percentage error.
It's the error you create by not using those terms. It's also called a remainder.
Okay.
Okay, all right? But the word error and remainder are synonymous in this
Okay.
case, okay? All right, so that's what we're working on now for this and Lagrange error bound. Okay? Lagrange.
Lagrange.
Yep. All right, now, so here's the example I'm gonna use with you, okay? I'm gonna give you a copy of it, but not right now, because I want you to watch it and not be able to see it. Okay. All right, so I'm not doing everything in the same order that the notes are, but the notes will be, because I'm skipping the first part of it. Because I know you know how to find the first four terms and plug it in and all that stuff, okay? Because all I'm gonna do is just write down the formula, okay? All right. This error that we were referring to, that's the error. It's called the remainder, but it's called the error. The error is the difference between the value of the real function
Minus
minus
Those.
the
polynomial.
polynomial. This pen is, it's not in sync.
Yeah, you have to recalibrate it.
No, it just go further down, see, it's better. But as I get further up, it goes further away.
Oh.
We're up to those sections for.
Story of my life. All right? And when we talk about the error, we talk about the absolute value of value. Okay? All right, so the absolute value. All right?
Right.
All right, so here we go. Now, here's the question. And again, you'll have this just a second. I'm giving you sine x.
Okay.
All right. I'm going to give you Maclaurin. I'm going to tell you there are three terms. And here's the question. It's the very same thing we did just a minute ago, except we are going a little farther with it.
There's no one. Okay.
All right, so obviously we could take 0.01, stick it into the sine function, here's our answer. All right? But we don't want to. We're going to use this representation, this polynomial representation, and then we're going to figure out what the error is in doing that.
So
Okay.
can we use a Maclaurin for this?
Yes.
Do we
You
have to
to
use
use-
Taylor?
Well, it's the same thing. It's just what the center is.
I mean, do you want us to use a Taylor?
They're the same thing.
It's the same thing.
I know, but like,
So
because
if-
the C is equal to 0.
So
we
if
don't-
you wrote down,
Can we use the shortcut? I mean,
if you wrote, okay, I'll answer that question. If you did this, if that's what you called it, it'd be fine. Okay. All right. The shortcut that you're referring to is memorizing the formulas on page 674,
Yeah.
whatever it is, and then just making adjustments. Now, in the
Yeah.
case of sine x, there is no,
Formula.
it's,
You gotta write it
I
out.
mean, it's just sine x. If I said sine 2x, then you would take the sine function on page 674 or 647, whatever page, and then plug in 2x everywhere you see an x. That's the shortcut that y'all are going to learn for Maclaurins. Okay, can't do that on Taylor. All right, so bottom line is, we would find out P of 3 is. I'm sure y'all already have it memorized. All right. Okay. Now. Okay. There.
Yeah, 'cause
Okay,
like-
and then the next one would be.
Because the signs are gonna be 0.
The next one would be X to the 5 over 5 factorial, blah, 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 okay?
Yeah.
All right, I'm gonna show you a little trick here. And I'm gonna teach, this is what I do as I go along. I show you other stuff that you're gonna see. I'll show it to you now because it's a good time to show it to you. Is this sine?
Mm-hmm.
What's the derivative of sine?
Cosine.
Cosine. And what is 3x squared? 3x squared over 3 factorial.
3x squared over 2.
3x squared over 6, in other words.
That's
Right.
just X squared
Oh,
over two.
no. Yeah, x squared over 2.
The next one would be,
X to the third over.
so the derivative of sine is cosine, right?
Right.
That's a representation for sine. So the representation for cosine is
That.
that. That's the formula for our cosine. And then when I teach you tangent, arctan is the same. Arctan is the same as sine, except there aren't any factorials. It's exactly the same as sine, but without factorials. That's how you're going to memorize these. See?
Okay.
It's going to get, and you know, e to the x is already x to the n over n factorial. So
Right.
there's 4 that you can learn real quick. Log x takes a little, you have to look at it a couple of times. Okay? But see, this is how I'm
Wait, so
trying
the
to.
cosine one's just a derivative?
Um,
The cosine one's just a derivative?
I'm kind of confused on what you were doing right there.
I was showing you how to create the polynomial representation for cosine if you knew what sine was.
Okay.
So it's just a derivative.
Okay.
Okay.
Mm-hmm.
So it is, it's just a derivative. All right. Well, guess what we're going to do if I gave you cosine?
Derivative.
Yeah, derivative.
What if I gave you cosine?
Negative derivative.
Integrate.
Or integrate.
You have to integrate. How do you go from cosine back to sine? You're going to integrate. How do you get from here back to here? It's integrate.
Well, can't you do the derivative of cosine as a negative sign?
Well, you can't. But remember, you're going to have a whole bunch of terms now.
Oh wait, well, that actually makes sense though, because if you
You're
read.
going to have. I mean, yes, what you said is correct, but you're going to have a bunch of terms here that are going to be weird. This is always not going to be this pretty right here like this.
Okay.
Okay, but when we'll do integration. All right, so let's move on. Okay. So where are we right now? All right, we've gone through the f prime, f double prime, blah blah blah, and there it is, right? Okay. Now is that the polynomial?
Mm-hmm.
Yeah.
Okay. So could we do this? To get the value of the polynomial,
Yes.
okay? And that will turn out to be 0.0998833. The days of using 1 or 2 decimal places is over. On these.
Oh,
no.
You have to carry them out, because I guarantee you, if you don't, when you get through, your answer is not going to look even reasonable. Okay. All
Wait,
right.
can we just use the calculator? Just copy it?
This is calculator, obviously. Yeah. Oh yeah.
Yeah, like
I can't expect you to find that answer.
I don't know what 0.1 cubed is.
I won't put like 0.099 in the calculator. I would use the
Oh,
original
you can do
value
that.
first.
Okay.
It'd be 1/10 times.
But for the answer, would you
So it'd
like
be one-
truncate it to
be one
3 decimal
1,000.
places, or would you still put 6?
No, you have to.
Right.
You're going to use
Yeah.
5 to 6 decimal places on these.
That's a
Because
lot.
look,
That's not bad.
we're going to end up with an interval.
Right.
Mm-hmm.
All right. And here's the low. Here's the high.
7.
Sine 0.01 is going to be in the middle, right?
Right.
All right. So the real value of the sine of 0.1 has to land between those two, somewhere in between those two,
Yeah.
to be correct. And if you don't use enough places, it could look like 0.099, 0.099, 0.099. See, so it would all three of them would look the same. So it wouldn't make any sense. All right. So now I'm going to make a note here that P of 3 of x is 0.099.
833.
Okay. The reason I have to do this is because I'm fixing to run out of room. Okay. All right. Okay?
Okay, so before you carry on, what is the real world application of this? Like why? So like, why would I need to use these instead of the actual equation?
Because of the estimating aspect of it, it's just, there's some word problems in here that I could give you, but they are
Terrible.
butt ugly.
Okay.
I mean, seriously ugly. And you can look at them.
No.
When you don't have access to a calculator, but you actually need to find out the number of a sign. I wonder when that'll happen.
All right. Okay. Is sine x itself equal to our polynomial that we came up with plus the remainder?
Yes.
Is sine x the real sine x?
Yeah.
The polynomial plus any of the remainder?
Yes.
Okay, so that takes care of all of it, right?
Yes.
Okay, now, so what we're going to do now is I need to define for you what the remainder is. All right. So we got three terms, right? All right. The very next term would be the fourth term.
Correct.
Okay. Now, that next term would be
0.
f of 4, right?
Right.
Remember that long definition?
Yeah.
Okay. I'll explain what z is in just a second. Okay. Is that the representation of the next term?
Yes, sir.
Okay. And we don't know what its value is, but we just know that that's it. Okay. So this is the f prime front, this is the x minus the center, and there is the factorial. Of course, that's 0. In our problem, that's 0. Now, what is this? All right, that's the key to all the problems that you will do on these eventually. Okay, this is Lagrange.
Okay.
All right, here's the key, is that value right there. Now, that value, and I stated it on the paper here, it has to be, because we're trying to find the maximum error. Leo, you okay?
Yeah.
Looks like you're about to fall asleep there.
Yeah.
You gotta go.
Go. Click.
Click the pen. Click the pen.
Maximum value.
Okay. It's the maximum value of the function. Now, for sine and cosine, it's easy, because the maximum value is 1.
1.
Okay. It's the maximum value of the fourth derivative. Okay, well, what's the fourth derivative? Well, sine, cosine,
Negative sign.
negative cosine, and back to sine, right? So the fourth derivative is
Sine.
sine. And the maximum value for sine is
1.
Okay, that's an easy one, right? So that value is 1. You will get problems that won't be sine or cosine. So you will find the fourth derivative or third derivative, or whichever one is
And
blue here.
And then derivatize
Take
that
another
again.
Then you will probably have to look at possibly its graph,
Or take another derivative.
find
Or
the
take
center.
another
I'll
derivative.
show you how to do this. Find the center and find the maximum. So if the graph is doing this, here's the interval. The graph is doing this, would the maximum be out there at that point?
yes.
That would be the maximum value you use in your equation. If the graph went downhill like that, then it would be at the front of the interval, wouldn't it? But it's the maximum value,
Okay.
okay, of that. Okay, so, and that comes in those problems over there, okay? You don't have to do that. But that's the idea. Okay. All right. So, what do we have, okay? Well, is this the remainder?
Yeah.
All right.
Well,
Now,
part of it.
Is that the very next term? All right. That term right there, the remainder, is less than or equal to all the rest of those added together. Okay?
Less than?
less than or equal to. The remainder is less than or equal to. All right, so
Yeah.
all other terms, okay? But that's the only term we care about. We don't care about the next term, the term after that. We only care about that one term.
Only the term after.
It
whatever-
describes everything that happens after that.
So that specific term is less than the rest of it?
By definition, it is.
So the rest of it meaning the ones that come
Because all
after?
the others would add up to a little bit, would add up to more than that.
Okay.
Wait, is it less than or equal to all everything behind, or is it just like
The sum of everything.
Oh, okay. There we go.
Okay, so this term right here would be for us, and I'm not gonna go through the trouble of erasing all this. That would be a 1,
X minus.
That would be
just X.
4.
x to the 4, and x is 0.4,
Oh,
right?
0.1.
to the 4.
0.1 to the 4. Okay?
So 1/10,000.
So that's this part right here, right?
Yes.
Okay? This is 0.0001 over 24.
Yep.
And then when you divide that out, you get 0.0000001.
Mr. Chair, can I get that test with you?
That's a lot of decimals.
Yep. You see what I
It's a
got?
lot of damage.
4.2 times 10 to the negative
4.2 times 10 to the negative 1, 2.
6.
Yep.
It's negative 6.
English.
Ah.
Sorry.
Do they care whether we put it in scientific notation?
No scientific notation, there'll be decimals.
Oh my. That's gonna be a lot of zeros.
Okay. Now this is on your paper. This is on your paper.
These have to be
First.
free response questions. Oh, I know what I'm doing for free response. I know what I'm doing free response practice on.
Okay? All right. So the remainder is equal to the difference between these two, which is less than or equal to that.
Mm-hmm.
Okay. So we're going back over here. And we have a formula. I'm going to erase and replace.
5 zeros.
0.00000. I was going to write the formula for this right here. All right, what do we find this to be?
Point
0.0998, yeah.
0.00.
1 0. 99.
Oh,
0.998. 33.
Okay. And y'all remember from your algebra days how to write solve the absolute value of inequality? Remember,
You have to like flip it.
you remove this.
I completely skipped inequalities. So I actually don't really know how to do them.
Yeah.
Uh,
Absolute value is less than or equal to that, so it's, since it's less than, remember how the rules on less than?
It's and, so
Between.
yeah.
And that's why I wrote it this way.
If it was greater, then it would be
Great.
It would be
Great or
another course.
less
Not this one.
than.
another course.
Another class, yeah.
Oh God.
All right, so would you add this coming back this way and add this going back that way?
Correct.
Yeah.
Yes.
All right, and so when you do that,
What is it?
you're gonna get,
Wait, what about the equal?
There's no equal, I don't think.
It's less than or equal to.
it's not, the equal goes away.
Okay.
Which is, oh, it's in that, sorry. 0.099. 8288 is what I came up with. And on the other end, I added it this way. 0.099 8372.
Oh my God.
So there's the there's the interval over which the value of sine 0.1 exists. All right, so then you take a calculator and you look up the sine of 0.1 radians. The answer is 0.09983341166,
Oh,
and I stop right.
Okay.
Is that number between those two numbers?
Yes. So you're getting to within a
I don't know how many. Tenths, hundreds, thousands, 10,000s, 100,000s.
hundredth millions.
In order to
Mil-
get an answer.
Can we get done? Oh, are we done?
But do you understand why if we...
Right, if you left them off, yeah,
it
you,
would be, all of them would be point
Not-
zero
oh,
nine
nine.
nine eight.
Yeah, 0.099.
yeah, they'd all be the same.
Not all the same.
thing. Obviously doesn't exist.
God.
No such exists. Okay? Now, is the first term that we dropped off called the error? Is the first term that we dropped off
Mhm.
that we didn't look at called the error?
Yes.
Okay. All right, so now,
It's more?
I feel like we haven't even gotten started.
you got to pull a Larzogium and drop the course?
No, I'm not gonna drop the class.
All right.
Even though I get a B, I'm not gonna drop. Jesus.
I'm just gonna use the same one because, but I'm gonna add another term.
Can you also show us a one that doesn't have such an easy maximum?
Well, I'll have to do a problem, but yeah, I'll show you.
Okay.
I'll be giving away a problem. But,
Oh, well then no, we'll just figure, we'll do it.
no, when you get there, I'll show you.
Okay,
But I need you to work up to that point.
okay.
All right. Okay, can we say that that's the polynomial for sine x?
Yes.
A polynomial for sine x. And we could add terms on forever, couldn't we?
Uh-huh.
All right. Now, they're going to ask you how many terms, this is an AP question, how many terms are required for the error to be less than or equal to
A certain
0.0001, for example.
Okay.
Oh.
All right? So what we're going to do is we're going to look at, whoops, we're still using the 0.1, right?
Yep.
All right? So we would then evaluate that term,
Yep.
okay? Is it less than this? Probably not. Maybe it is, I don't know. It's, what was it, 0.1? 0.099, right?
Yeah.
That's not less than this, is it?
0.099.
Okay, we would then do 0.1 to the fifth power over 5 factorial. 0.1 to the fifth power over 5 factorial. If that number comes out to be smaller than 0.0001, what is x to the 5 over 5?
It is. It's 8.33 times 10 to the negative 8.
Is there a factorial
That
button?
8, what did you say? 8?
8.33, and then it keeps repeating 3s times 10 to the negative 8.
Okay, well, that's gonna be definitely smaller than 0.0001, isn't it?
Yeah.
Yeah. So would this be the term for that right there? That you would, is that where you'd stop?
Yes.
So how many terms does it take? 2. Okay. Because is that the error right there?
Mm-hmm.
For the error to be less than that number, you take 2 of these, and then they'll say find the
Oh,
sum.
I see.
So then all you just add these 2 numbers together.
Wait, is there a way to input factorial?
You can just like plug point 1 out.
Go to math,
It's math
probability, PRB,
and 4, probability 4.
4.
Oh,
Okay. All right. Now that is pretty much the definition of Lagrange error bound.
So okay, so you get your equation and you just plug in whatever value it is, so
0.1 or whatever, yeah.
So, and your value, your error has to be less than 0.0001.
You're trying to find the term
Yeah.
that gets you a value smaller than whatever they gave you, in this case, point.
Okay, so you get, so when you plug in 0.1 to the x over 5 to the 5 factorial, you get that number, that 10 to the negative 8.
If, 0.1 to the fifth divided by 5.
Yeah, it's a really small number. So it takes 5 terms?
2, 1, 2. Because
Those two.
that's terms 1, 2, and 3, and this is sine. And so for sine, some terms will just end up being 0 because
So it only takes 2 terms. 2 actual terms. Because 0 doesn't.
our
You don't
center is
count
0, and if the
Right,
sine is 0,
center is
then
0.
That, Leo, Sam, that is the definition of sin x right there. Not having the 0, and the 0, and the 0, and the 0. That's not the definition, okay?
That's the definition?
That's the definition of what sin x is.
Okay.
Those 2 terms right there.
Okay.
Yeah, it's not all the zeros. That's why if it says n equals 3, stop when the power is 3. You don't go to 3 terms. See, the power, n is the power that you use, okay, as your defining value. Okay. So they could ask you for the sum with an error less than this. So you just add these 2 together. How many terms are needed for the error to be less than this?
That's where we do.
2 terms. Okay. And those are things that we're going to be doing.
Okay.
Part of Lagrange error bound, okay? Okay. All right. Now, I'm going to give you, this is the Lagrange error bound. This is the worksheet that says tomorrow. Now, I'm not giving you an official assignment over this because this starts the lecture that I just did. So you can either start on these today or you can, if you want to.
So are we done?
Yep.
Yeah, I'll pass it.